Good evening, good morning, good afternoon, good mid-evening, good mid-afternoon, good morning and evening and night to all of the continents that we know of, anyways, all of the planets that we know of, and I will list them off in just a bit here. Welcome Asia, welcome Europe, welcome Africa, welcome North America, South America, Australia, New Zealand, Antarctica. Everybody, most welcome. I am sorry, I wanted to start this live a little earlier, but I have been suffering from some incredible pain in my abdomen due to a menstruation situation. So anyways, hope you understand. Acacio, hello my friend. Hola amigo. How are you? 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 Everybody, thank you so much for being here. Thank you to our new friends. Thank you to our old friends. Thank you indeed to all our family and friends and the friends and neighbors of those who will be joining. Hopefully you can share the live and invite many more people, entire countries worth of people to this live stream so that we can share the joy and the abundance indeed that we are about to get into. Today we will finish up the book A Brief History of Time by Stephen Hawking that we have been kind of following like a hawk, and we have been talking about the most exciting topic of time travel, wormholes, and string theory as far as a candidate for the grand unification theory. We looked at string theory, of course, which is this great big topic that people worked on sort of after Einstein's death, and after Einstein's death, and unfortunately Einstein passed away without successfully coming up with a grand unification theory, and even till now we don't really have a testable candidate for grand unification theory that people are all sort of sold for. So that's sort of where we are in the book. It's towards the end really, and today we will just conclude and say hi to everybody and hang out for a while and read all your comments and say your usernames out loud and say good evening to everybody and give everyone a shout out. Hola amiga, yo estoy bien y tú cómo estás? Bien, muy bien, I'm good. I think you're asking how I'm doing, and indeed I'm doing all right. Thank you, Acacio. Gracias, Acacio. How are you? It's so good to see you. Thank you for making it to the live stream, and thank you everyone else who's going to be joining. Let me go get my other phone. It's over there. Whoa, got you early for once. Thank you, Doro. You are here. So Doro, tell me what was happening last night with that other guy. So I only caught in the middle of the chat. How did that big fight start with Clint? Before it gets crazy again, I want to know your take on this whole matter. You should have seen what was happening towards the end of the chat last night. Goodness gracious me. Chickpea was asking the poor guy to eat crayon, and I just couldn't keep up with the chat anymore, and I finished up the topic of the night, and that was it, and we went to bed, hopefully all of us in one piece. Let me go get my other phone. Thank you so much again for thank you so much again for being here. Thank you. I got out of that, but basically Clint said some dumb stuff, and Ver kept saying he drank glue. Oh my gosh. I went back and read it. It was really funny. Well, I just kept seeing glue and crayon constantly from the corner of my eye as I was trying to finish up the topic yesterday, and it took a lot of concentration to talk about the thing yesterday, so I didn't see the full chat. When I got into my spiel, I was in a different sort of dimension and mindset. Yes, it was very distracting. You're right. It was very distracting. I didn't like that at all. Even for me, it got too weird. Okay. I wanted to understand how this was triggered, but never mind. I think yeah, we can move on. Why is no one here? Everybody, we do hope you'll be joining. Let me get my other phone and share the live. Is Acacio new? Sometimes it gets wild. No, Acacio is not that new. He's been attending, but he is my Spanish speaking friend. I don't think he is like that new or new at all. Okay. Enjoy the madness. Enjoy the madness, Acacio. Or not. You can just enjoy the physics, Acacio. And Acacio, maybe you can teach me a few more things in Spanish while we're waiting for a few more people to join. And let me share the live. Thank you, everybody. Why is nobody here? What day is it? What day is it? Hey, Google. What day is it?
It's Thursday, May 8th, 2025.
Like a human being, your stream should be enjoyed in full. Physics, cats, and the chat. That's true. The chat is a big part. The chat is very full indeed. So it's May 8th. Thursday. Okay. I don't know why more people are not here. Hello, thank you so much for joining. Can you please like the live and can you say something in the chat so we know who you are? And or also you don't have to. You're welcome either way. You're welcome. Was cool seeing Reese though. I know. It had been such a long time. It had been such a long time indeed. Hello, welcome. Welcome to the live, my friends. Like when 3 reads gets a 9 out of 10. Excuse me? He has the same as me? How come? You know so much and you sound pretty natural in Spanish. You surprise me. Well, that's because I am multilingual, so I can do the accents pretty well and I can say the sounds, but I'm still not fluent in Spanish and I know quite a few words, but that doesn't mean I can hold a conversation, and that's where I'm lacking. I would love to know more Spanish and I wish I could hold like full conversations. Ooh, today I got Brazilian food and they saw me and they were of course expecting at least Spanish or something, and I was like, can I get this one? I hate that I have to speak English with people who can speak other languages, you know? But I don't know enough Spanish or Portuguese, so, or French or Italian. But because I speak Hindi, Bengali, you know, Indo-European languages, there's a lot of like sounds and stuff that are similar. So I'm glad I sound pretty natural in Spanish. Thank you. Thank you. Literally lives in Belgium. I do. Basically Belgium. Okay, I'm gonna share the live. Oh piya, 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 tumsa nahi koi priya. I think it's Priya. Oh Priya, 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 tumsa nahi koi priya. Sometimes I sing this song for my babies. Hi, Steven. Can you please like the live? तू खुश रहे जहाँ भी रहे ये मेरे दिल की दुआ हाँ हेलो चिकपी कैसे हो जी तू खुश रहे जहाँ भी रहे ये मेरे दिल की दुआ Nobody's here. Shut up. Do not fight with that kid anymore. I think he's a kid. Don't tell him anything today. Just leave him be, ignore him, and maybe he'll shut up. You know what I mean? Sing with me. Oh Priya, 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 तुमसा नहीं कोई प्रिया तू खुश रहे जहाँ भी रहे ये मेरे दिल की दुआ हाँ Are you guys even enjoying my song or not? I'm in the house. No need to give me a standing ovation. What do you mean, Steven? What do you mean? What do you want me now? तू खुश रहे जहाँ भी रहे ये मेरे दिल की दुआ हाँ ओ पिया पिया तुमसा नहीं कोई पिया I'm in the mood for some singing today. Azimo Shah Shahenshah. I've always liked how Indian women make all those vocal noises. Which noise? Excuse me, Moa. What noise are you talking about? What noise? This is called sounds. Okay, sounds. Clint loves glue, like how Chickpea loves Oindri. Oh, Oindri loves Chickpea. Which noise? तू खुश रहे जहाँ भी रहे ये मेरे दिल की दुआ All the matter of the universe is made out of the No. So this is a wonderful question that Akasio has asked. So the ordinary matter of the universe is only 5%. Chickpea reference? That's just Chickpea saying I like Chickpea. I'm not in the mood today for teaching. But no, actually I will answer the question in great detail in just a second. We are live. I did share it, right? I did share it. Okay. So Akasio, you have done a great job of asking a great question. Muchas gracias. Hopefully I said that right. So, the ordinary matter of this universe, things like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon. I'm a little proud of that. Those things, ordinary matter, make up only about 5% of the matter of the ingredients of the universe. Most of the matter is actually dark matter. So you're saying, I mean all the matter that you can see or detect in the universe. So dark matter we cannot see because it does not interact with light, but we can detect because it does interact with gravitation. So most of the matter of the universe is dark matter, which we know not of exactly what it is, what it entails, what it comprises. Exactly what dark matter is an unknown, but we do detect it. We do detect some extra invisible matter that does not interact with light, but does interact with gravitation. And that is more, much, much more in the universe. Most of the matter in the universe is actually dark matter. Most of the stuff in the universe, just most of the fraction of the energy density of the universe is contributed to by dark energy. So we talked about this. Around 70% of the energy density is dark energy, around 25% is dark matter, and around 5% is ordinary matter. So all of that stuff that's in the periodic table and what we're made of is only 5% of the energy density of the universe, okay? And we talked about this in our cosmology lives. If you go back to our lives in the past, and I will try to put them all in a playlist maybe at some point, we've talked about this quite a bit, where we talked about the 5 major cosmic, well, not even major, just period. 5 cosmic ingredients in the universe, right? What is the universe really made of? If you want to look at it and think about it very simply, then it is photons. This is light as you know it. Baryons, these are the ordinary matter, mainly protons and neutrons. Neutrinos, these are weakly interacting leptons. Dark matter, I'm trying to do the 4th finger here. Dark matter, which is matter that does not interact with light but does interact with gravitation and pretty much dominates matter in this universe. And then lastly, dark energy, which is responsible for the expansion of the universe, which is also a little bit mysterious, exactly why the universe is expanding rather than staying static, etc., etc. And we've talked about it, but the expansion of the universe is accounted for by dark energy, the 5th ingredient of the universe, or 5th cosmic ingredient. So those 5 things in the cosmic inventory really make up and give us the energy density of the universe right now. And also it helps us to understand the evolution of the universe from the Big Bang. So indeed, we and things like us, ordinary matter, all of the periodic table, everything, chemistry, all of that, all of the standard model of particle physics so far. I mean, some things could be beyond standard model in particle physics, but we have this thing called the standard model of particle physics, which kind of encompasses the particles we've found and the types of interactions that we understand normally under particle physics and quantum mechanics so far. And everything there is all ordinary matter, considered to be ordinary. We still don't know exactly what dark matter is made of, what the particle nature of it is, etc., etc., but it's an ongoing research topic and people are looking. Okay, and one of the candidates for dark matter, of course, early on was neutrinos, but we've kind of concluded that they are not going to account for the majority of dark matter. Okay. So, great question. I mean all the matter that you can see or detect in the universe. I liked how you put it. All the matter that we can see are ordinary matter, but all the matter that we can detect is both ordinary matter as well as dark matter, where dark matter is much more than ordinary matter. Okay? Nathan says, B, hello, looking great tonight. Thank you, Nathan. I'm glad we caught you before your bedtime. I used to, as a kid, sniff candles. Hello. Hello, Professor Nick. Geerr. Or sorry, there's just the one E. Good evening. Can I get a shout out of my full name? Hello, Professor Nick, Geerr. How are you? So let me say hi to everybody once again. Acacio, hello. Doro, hello. Steven, hello. Chippy, hi. And then Professor Nick. Anybody else want to say hi? Go ahead. And Nathan. I had a nap earlier. I should be sleeping. Yeah, so I'm a little under the weather tonight, actually. I don't think I'm going to be here very, very long. Huge. Hugh. Oh gosh, it just dawned on me what that meant. Hugh. I really did look, I really did read that as Hugh. Janus. Oh gosh. I didn't get it until just now. The Hugh part, I really did see that as Hugh. Speaking of, okay. Wow. Anyway, that was an epiphany for me just now. Thank you everybody for being here. Can we get 10 likes? I went up on Skyline Drive with my mom today. We saw several deer today. It was so cool. All right, so we are going to finish up the conclusion part of this book, A Brief History of Time by Stephen Hawking. We have already talked about a lot of really interesting topics, including but not limited to, of course, black holes, wormholes, time travel, and string theory as a grand unification theory candidate. And now we're going to start to do the conclusion. Before you read, got a question for you. Of course, what is it, my friend Doro? Yeah, of course. Stephen is going to write books and we will read some. Yes, of course, we will get any chance we can get to read some of his books. Of course. And somebody already requested that that happens during the day. So I can read Stephen's book at some point. We already planned to. We already planned to do a chapter reading once he... Yeah, we already planned to do more. Once he adds a full chapter... Once he adds a chapter, then I'll do that chapter reading. And I can do it at a time that works for everybody. Okay, like maybe on a weekend or something. So that the full Stephen crowd can attend. I went up on Skyline Drive. Will you read more of Stephen's books? I was like, I am reading Stephen's book right now, Stephen Hawking, but you, of course you meant our friend Stephen. I had to do a double take. Thank you. You should do some physics tricks or a show and tell type video once. I'm doing a physics trick all the time here. See the angular momentum one? And then I can bring my arms in and that tells you about angular momentum conservation. Stephen Hawking went to... Oh, okay. All right. So we will talk about the conclusion of this book while I have patience with this particular class. And we will keep going. Oh, Baji. Baji is stretching over there as I speak. So we find ourselves in a bewildering world. We want to make sense of what we see around us and to ask, what is the nature of the universe? What is our place in it and where did it and we come from? Where? Why is it the way it is? Now we know that specifically speaking, we, as in you and I, we come from a gigantic nebula, gas cloud thingamawitch, which condensated to make the sun and the planets in our solar system. And we are pretty metal enriched, as in we have nice metals in our system. You know, Earth even has gold. So we cannot be coming from a very early star, which would have been metal poor, etc., etc. Those stars had died and made new stars, and that made new stars. And whenever a star dies and spews all of its material into the interstellar space, ultimately you might make sort of a nebula or a gas cloud, and ultimately then here we are. And so having something as heavy as gold is an indicator that we cannot come from something too primitive. Okay? So that's in a little bit of a tidbit from me about where we come from. Let's see what he is saying as far as the universe goes, because what I just said is more specific to our solar system and this galaxy. I think he means the universe, okay? To try to answer these questions, we adopt some world picture, just as an infinite tower of tortoises supporting the flat earth is such a picture. So is the theory of superstrings. Both are theories of the universe, though the latter is much more mathematical and precise than the former. Both theories lack observational evidence. No one has ever seen a giant tortoise with the earth on its back, but then no one has seen a superstring either. However, the tortoise theory fails to be a good scientific theory because it predicts that people should be able to fall off the edge of the world. This has not been found to agree with experience, unless that turns out to be the explanation for the people who are supposed to have disappeared in the Bermuda Triangle. The earliest theoretical attempts to describe and explain the universe involved the idea that events and natural phenomena were controlled by spirits with human emotions who acted in a very human-like and unpredictable manner. Can we get 10 likes? Doro, can you do that message thing that we pin? These spirits inhabited natural objects like rivers and mountains, including celestial bodies like the sun and moon. Some woo-woo stuff. They had to be placated and their favor sought in order to ensure the fertility of the soil and the rotation of the seasons. Gradually, however, it must have been noticed that there were certain regularities. The sun always rose in the east and set in the west, whether or not a sacrifice had been made to the sun god. Further, the sun, the moon, and the planets followed precise paths across the sky that could be predicted in advance with considerable accuracy. The sun and the moon might still be gods, but they were gods who obeyed strict laws, apparently without any exceptions, if one discounts stories like that of the sun stopping for Joshua. Okay. At first, these regularities and laws were obvious only in astronomy and a few other situations. However, as civilization developed, and particularly in the last 300 years, more and more regularities and laws were discovered. The success of these laws led Laplace at the beginning of the 19th century to postulate scientific determinism. People loved determinism, by the way, until quantum mechanics came about and disturbed that. That is, he suggested that there would be a set of laws that would determine the evolution of the universe precisely given its configuration at one time. This is what I kind of talk about sometimes, this deterministic nature of physics that people were so used to, where basically they're used to being able to have a set of laws or a set of equations that will then be able to predict the future state of a thing. Like if I give you the equation of motion or the state for the moon, you will be able to tell me with equations where the moon will be in like 100 years from now. So this sort of thing, the equation of motion for example, would give us position as a function of time. So literally, you plug in the time, you get the position out. It's pretty powerful when you think about it. Like when when people who like classical physics and people who are used to that, because I mean that is the older one, is it basically just gives you an answer. Like once you know the equation, once you know the set of laws or rules that something follows because of knowing physics and because of postulating physical laws, after that you can just have an answer when you're asked. And especially something that comes up a lot is the position of something as a function of time, whether that be the sun, the moon, you, your car, hopefully, you know, your home, mostly at rest, things like that. So Laplace's determinism was incomplete in two ways. Laplace determinism was incomplete in two ways. It did not say how the laws should be chosen, and it did not specify the initial configuration of the universe. These were left to God. God would choose how the universe began and what laws it obeyed, but he would not intervene in the universe once it had started. In effect, God was confined to the areas that 19th century science did not understand. We now know that Laplace's hopes of determinism cannot be realized, at least in the terms he had in mind. The uncertainty principle of quantum mechanics implies that certain pairs of quantities, such as the position and velocity of a particle, cannot both be predicted with complete accuracy. So then comes quantum, which then does not allow you to predict things with a lot of certainty or things with unlimited certainty. There is a uncertainty principle that limits your puts a limit on your observations as far as the certainty, such as, so you cannot know both the position and the velocity of a particle with complete accuracy. There is a limit to the certainty there. Quantum mechanics deals with this situation via a class of quantum theories in which particles don't have well-defined positions and velocities but are represented by a wave. These quantum theories are deterministic in the sense that they give laws for the evolution of the wave with time. Thus, if one knows the wave at one time, one can calculate it at any other time. Thus, if one knows the wave at one time, one can calculate it at any other time. The unpredictable random element comes in only when we try to interpret the wave in terms of the positions and velocities of particles, but maybe that is our mistake. Maybe there are no particle positions and velocities, but only waves. It is just that we try to fit the waves to our preconceived ideas of positions and velocities. The resulting mismatch is the cause of the apparent unpredictability. Hello, everybody, once again. In effect, we have redefined the task of science to be the discovery of laws that will enable us to predict events up to the limits set by the uncertainty principle. The question remains, however, how or why were the laws and the initial state of the universe chosen? In this book, I've given special prominence to the laws that govern gravity, because it is gravity that shapes the large-scale structure of the universe, even though it is the weakest of the four categories of forces. So isn't that so crazy that gravity is the one which is so universal? Everything is affected by gravity, but it's also the weakest of the four categories of forces, and very hard to unify it with the other three types. We talked about that a lot yesterday. So, okay, the laws of gravity were incompatible with the view held until quite recently that the universe is unchanging in time. The fact that gravity is always attractive implies that the universe must be either expanding or contracting. According to the general theory of relativity, there must have been a state of infinite density in the past, the Big Bang, which would have been an effective beginning of time. Similarly, if the whole universe recollapsed, there must be another state of infinite density in the future, the Big Crunch, which would be an end of time. Even if the whole universe did not recollapse, there would be singularities in any localized regions that collapsed to form black holes. These singularities would be an end of time for anyone who fell into the black hole. At the Big Bang and other singularities, all the laws would have broken down. So God would still have had complete freedom to choose what happened and how the universe began. When we combine quantum mechanics with general relativity, there seems to be a new possibility that did not arise before, that space and time together might form a finite four-dimensional space without singularities or boundaries, like the surface of the Earth, but with more dimensions. So we must thank Stephen Hawking for combining quantum and classical, especially with the black hole, and giving us temperatures of black holes. It seems that this idea could explain many of the observed features of the universe, such as its large-scale uniformity and also the smaller-scale departures from homogeneity, like galaxies, stars, and even human beings. We are nothing but a little bit of a fluctuation. It could even account for the arrow of time that we observe. But if the universe is completely self-contained with no singularities or boundaries and completely described by a unified theory that has profound implications for the role of God as a creator. Einstein once asked the question, how much choice did God have in constructing the universe? If the no boundary proposal is correct, he had no freedom at all to choose initial conditions. He would, of course, still have had the freedom to choose the laws that the universe obeyed. This, however, may not really have been all that much of a choice. There may well be only one or a small number of complete unified theories, such as the heterotic string theory. It's one of the string theories that are self-consistent and allow the existence of structures as complicated as human beings who can investigate the laws of the universe and ask about the nature of God. Even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science of constructing a mathematical model cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Is the unified theory so compelling that it brings about its own existence? Or does it need a creator? And if so, does he have any other effect on the universe? And who created him? Up to now, most scientists have been too occupied with the development of new theories that describe what the universe is to ask the question, why? That describe what the universe is to ask the question, why? On the other hand, the people whose business it is to ask why, the philosophers, have not been able to keep up with the advance of scientific theories. In the 18th century, philosophers considered the whole of human knowledge, including science, to be their field and discussed questions such as, did the universe have a beginning? That was all their problem. However, in the 19th and 20th centuries, science became too technical and mathematical for the philosophers or anyone else except a few specialists. So that's why we say Doctor of Philosophy. This used to be what people generally studied, is philosophy. Philosophers reduced the scope of their inquiries so much that Wittgenstein, the most famous philosopher of this century, said, "The sole remaining task for philosophy is the analysis of language." What a come down from the great tradition of philosophy from Aristotle to Kant. So basically, used to be that philosophers were really sort of the scientists of the old days, and there wasn't really science practiced like it is now. And they used to be a lot more important. Now, science has kind of taken over. You can't just philosophize. And science has become very accurate, and there's a lot of work, a lot of engineering actually in science that makes like experimentations and measurements possible. So it's not just about thinking and philosophizing, it's about these measurements. However, if we do discover a complete theory, it should in time be understandable in broad principle by everyone, not just a few scientists. Then we shall all, philosophers, scientists, and just ordinary people, be able to take part in the discussion of the question of why it is that we and the universe exist. Hello! If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God. Hello, El Chalin, says Chow Chow Chow. Thank you so much for liking the live. For then we would know the mind of God. I think I'm just curious in general. I don't have to know the mind of God. I would just be curious about the universe, you know? I am curious. It's just incredibly interesting. OCB. Oh, that's right. Well, that was the book. Top G says, if you knew the mind of God, you'd be colossally bored. Actually, yeah, it is nice to have something to pursue, for sure. So that was the end of this book. Then we have a few little blurbs on some scientists. I have to fill up my water. Give me 1 second. Ah, and I am in some pain, so I might have to cut this short today. Ah. Oh, let me show you Sachi Mama. Hi, Sachi. Sachi Mama, you're so cute. Boy, oh boy. Oh, okay. He can talk about God. It's okay. What are you doing? Don't pick a fight with my new viewer. You go ahead, Top G. I did mention it. Chickpea. Stop it. Don't let them get to you. Don't let them get to you. Top PUBG, I have some extremely naughty moderators. They're pulling your leg. Don't let them get to you. Don't do it. Don't do it. Don't talk to them. Don't even talk to them because they will keep it going. They need a fight. They're itching to fight. Chickpea, how are you doing? I'll be waiting for when you spam it. What? I knew it. See? I knew he's trying to pick a fight. That's what this is about. That's what this is for. I felt like I was being pummeled upon entrance. El Challen says relatable. Hi, El Challen. Doro is not fighting today. He's not contributing. Thank goodness. All right, any questions? The universal or physical constant, what it defines or determine. The universal or physical constant, what it defines or determines. So I don't know which one you mean. So the speed of light is a constant of nature. Oh God, let me not. Why do I read the comments? They always distract me. So the speed of light is, the speed of light in vacuum is a constant. That's one constant. It signifies nothing can really go at the speed of light. And it's also the case that the speed of light is a constant of nature, just period. No matter what speeds you're going at or the frame might be at, they will still experience the speed of light as a constant, which has a lot of deep implications and insights in itself. Sorry, I'm picking at a scab here on my leg as we speak. The next thing is the cosmological constant. So since you asked about a constant, I'm just kind of thinking about what constants we might have talked about. So the next thing we can think of is the cosmological constant. This came up when Einstein was faced with the question of why doesn't the universe just collapse upon itself under gravitation? So in order to keep the universe static against gravity, he introduced a term called the cosmological constant in his mathematics. And that has kind of come a long way, where we now know that the universe is actually expanding, and it is responsible for the expansion of the universe. And we also call that dark energy, where the cosmological constant is basically a certain set of parameters or a certain case of the parameters for dark energy. Okay. What else? Let's see. There is a lot of mods. There's not a lot of people here today, but there's the mods. Why did Schrodinger's cat cross the road? They give you a hard time at first, but they'll warm up to you. Don't worry. They'll warm up. Don't worry. Okay, I need to check one thing. What is going on with my? Okay. Any other questions? You should comment, El Challen. I plead the fifth. they're nice to El Chalin now, as in they leave him alone. Just wait for another new guy to come in. Stick to the chatters. You're not ready for me. When you're a new guy here, or well, hopefully not a new girl. I will not let them pick on a girl. Just don't even try. I very rarely get women on here, so if you're a woman, just raise your hand. And I got you, babe. I got you. Just raise your hand. Raise your hand if you want garlic chicken or a woman. As in, if you are a woman. So, you feel discriminated? Good. It's discernment, not discrimination. Got it? Got it? So, just, if you're a new guy, just wait for the mods to pick on the next new guy, and then you'll be safe. Totally safe. Just totally safe. It's such a safe environment here. Such a safe environment. I ate protein today. I ate a bunch of meat. Well, not really, because I can't eat a bunch of meat. I tried. It was so hard to chew. I'd so much rather eat veggies. Is a gunner? Chickpea, what are you doing? What are you doing? It's okay. I read it. He's a gunner. Got it. Next. Next question. Next question. I'm not going to start a new topic today. I just wanted to conclude that book and return it to the library. If you're a Nike boy or girl, just do it. Just do it. Ooh, should I sing some songs for you guys? Which song? Which song? Einstein's connection with the politics of the nuclear bomb is well known. He signed the famous letter to President Franklin Roosevelt that persuaded the United States to take the idea seriously. Simping? Who is simping? Stealth Blooper says I like turtles. Hello. Hello, turtles. Hello. What song should I can you? If you're joining, you can go back and rewind the live. Oh, I'm getting cramps. Oof. Oof, 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 oof. Can we get 10 likes? I do have cramps. I've had cramps. I've been doing this whole thing with cramps. Aha! Get mental. Mental. Excusez-moi. दिल ये है चाल से. I'm gonna sing Chaya Chaya. I'm gonna sing Chaya Chaya lyrics. This stream is about to get mental. You're mental. Akasio, have you not been to my live where I discussed the heavier elements? The first two elements, hydrogen and helium, were made in the Big Bang. Mostly, well, okay, no. Most abundant element in the universe is hydrogen. I'm not gonna sing, I don't know that song. I'm not gonna sing that one. The most abundant element in this universe is hydrogen. I don't know why the ice cream is not here yet. I'm lactose intolerant, so I can't eat a lot of ice cream. So helium was also made in the Big Bang, but then stars also make helium and above. So the heavier elements, including helium and everything above, are made in stars. We have covered this in the past. You might want to go back and look at all those lives where we covered the heavier elements. Okay? There's probably a live stream episode called Heavier Elements. Please refer to that. For now, I will be grumpy. But, long story short, hydrogen was given to us by the Big Bang. Everything else by stars, okay? A little bit of helium was also given to us by the Big Bang, and trace amounts of lithium. I would say hydrogen, helium, and trace amounts of lithium were given to us by the Big Bang. And then everything else was made in the stars much, 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 much later. Okay? Much after the beginning of the universe, okay? Hello, Michael Gaming. Thank you, Acasio. Thank you, Acasio, for the questions. Thank you. Hello, Michael Gaming. Okay, I'm gonna sing now a song. Just realized that my dress is quite torn. Guess I cannot wear this out. It's torn on one side. What the frick? Good thing I work here. I don't know that song. जिनके सर हो इश्क की छाओ. Michael Gaming, do you know this song? He'll know. पाँव के नीचे जन्नत होगी. जिनके. I need to lie down. चल छैया 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 चल छैया 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 छैया. जिसकी जुबान उर्दू की तरह. I can't even. Hey, can you please like the live? Can we get 10 likes? Fine, I'll do the Star Spangled. Let me get the lyrics up. But let it be known that I prefer to sing Chaya Chaya. I'm that type of American who likes Chaya Chaya more. Star Spangled Banner lyrics. Okay, where are you? Where are you, lyrics? Oh, why are you opening YouTube, for God's sakes? For God's sakes. For God's. I did have to kind of know this for my America test, I think. Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming? Do we have to stand for this? Okay, I'm gonna lie down. You guys can come with for a bit. I'm gonna lie down. Can we get 10 likes? I'm gonna lie down and be on live until we get 10 likes. Then I'm gonna go to bed. This is too much. Here's Sachi Mama. Sachi! I'm not well today. Maybe I'll be here tomorrow. You're being picked up. I am unwell. I am most unwell. Anything else? Audrey is being visited by her aunt. Is being visited by her aunt. Aunt Flo. I got hit by hail today, got strick. Good night, get better. Thank you. Thank you, Acacio. Thank you so much. Buenas noches. Buenas noches. Good night. Sleep tight. Can we get 10 likes? Buenas. Good night. Sleepy tight. Favorite country is Nepal. Great. Okay. Okay. Say hi to Sachi. And Belgium. I got 10 likes. Thank you, everybody. There's my Sachi mama. Oh, he's so cute. Sachi, you're so cute. You guys want to see Sachi? Oh, you guys can see Sachi. Hi, Ray. Alright, guys. I have to rest. Good night. Sleep tight. Maybe I'll stay on the chat for a bit, but good night. Stop it. Good night.